right now. Scientists are watching natural warning signs they take very seriously. Before earthquakes, eruptions, floods, and powerful storms, nature sends signals. Subtle changes most people miss, changes that feel ordinary, until they aren't. But scientists don't. Some of these warnings have saved lives, others were ignored. And when they were ignored, the consequences were devastating. These are 15 natural warning signs that scientists are concerned about. Animals leaving an area without unobvious reason. Pausa silenciosa. Sometimes the first warning doesn't come from instruments, or satellites, or sensors, it comes from animals. Pause. A calm word text equals animals. Notice first there are moments when entire groups suddenly leave an area with no visible threat. No fire, no storm, no human disturbance, just absence. Poses. In multiple documented cases, snakes have abandoned their burrows days before major earthquakes. In other regions, birds have changed migration routes just before extreme weather events. Marine animals have moved to deeper water ahead of powerful storms. Pulse. A calm word tax de nous bay of your scientists believe animals can detect subtle changes we can't. Low-frequency vibrations traveling through the ground. Tiny shifts in air pressure, chemical changes in water or soil. Signals that don't register as danger to us, but do to them. Pause. A silenciosa. This behavior doesn't predict exactly what will happen, and it doesn't happen every time. But when animals leave an area all at once, experts pay attention. Pause. A calm word text equals scientists pay attention because in past events where these warnings were ignored, the outcome was often severe. Pause. A silenciosa. It's one of the oldest signals nature gives us, and one of the easiest to dismiss. Pause. 14. Sudden changes in water levels. Pause. A silenciosa. Water is supposed to move gradually. Rivers rise and fall. Seas follow predictable rhythms. When that pattern suddenly breaks, scientists get concerned. Pause. A con word text equals water behaves strangely in several major disasters. Water changed first. Before large earthquakes, rivers have dropped rapidly without warning. Streams slowed, then fell silent. In some cases, wells drained overnight, or surged upward for no clear reason. Pause. A silenciosa. These changes often happen when the ground shifts underground. Rock layers crack, pressure builds, and water trapped below the surface is suddenly pushed elsewhere. Pause. A calm word text equals something is moving below. In coastal regions, the signal can be even more dramatic. Before major tsunamis, the ocean has been seen pulling back unnaturally far from shore, exposing the seafloor, stranding fish, and leaving beaches eerily quiet. Pause. A silenciosa. This isn't low tide, and it isn't normal. It's the trough of a massive wave arriving before the crest. Pause. A calm word text equals do not ignore this. In multiple documented cases, people who recognized this sign and moved inland survived. Those who stayed in. Pause. A silenciosa. Today, scientists monitor rivers, wells, and coastlines with sensors designed to detect sudden, unnatural changes in water behavior. Because when water moves without explanation, it often means something far larger is already in motion. Pauses. 13. Cracks in the ground and shifting land. The ground is supposed to feel solid, stable, unmoving. When that changes, it's rarely subtle. Before major landslides and earthquakes, the land often gives warning. Small cracks appear where there were none before. Roads begin to bend. Fence posts tilt. That trees slowly lean downhill. These signs aren't sudden disasters. They're slow failures in progress. Rock layers begin to separate. Soil loses its grip. Gravity starts winning, quietly in some regions. People hear it before they see it. A deep rumble beneath the ground. Sharp cracking sounds. Branches snapping with no wind. Survivors of major landslides have described these noises just minutes before entire hillsides collapsed. In Norway, scientists monitor mountains where cracks grow a few inches every year. In parts of Asia and South America, entire villages are relocated when land deformation crosses a critical threshold. Because once the movement accelerates, there's very little time left. Modern monitoring systems now track ground deformation using satellites, GPS stations, and laser measurements accurate down to millimeters. Not to predict the exact moment, but to recognize when the land has entered a dangerous phase. When the ground begins to change shape, it's not adapting, it's failing. 12 unusual sounds coming from the ground or the air. Sometimes the warning is invisible. You hear it before avalanches, earthquakes, and major ground failures. People have reported sounds that don't belong. A deep hollow thump beneath the snow, low rumbling with no storm, sharp cracks echoing from underground. In mountain regions, experienced guides know this sound well. It's often described as a sudden collapse beneath the surface, a sign that a weak layer has just failed. When that happens, the conditions are already unstable. In earthquake-prone areas, residents have described hearing distant, roaring or grinding sounds shortly before the ground begins to shake. These noises don't come from the surface. They come from stress releasing deep below. Scientists believe these sounds are caused by rock layers shifting, fracturing, or suddenly releasing pressure. Energy moves, vibrations travel, and in rare moments we can hear it happening. Modern monitoring stations now include acoustic and vibration sensors designed to detect these signals long before damage appears above ground. Not because sound predicts disaster, but because it confirms that something fundamental has already changed. When the environment begins to make unfamiliar noises, it's not background sound. It's a warning. 11 strange lights in the sky without a storm. Light usually has an obvious source: the sun, lightning, city glow. When light appears without one, scientists take notice. Before several major earthquakes, people have reported flashes in the sky: blue, green, white, sometimes lasting only a split second, sometimes spreading across the horizon. No thunder, no storm, no power lines nearby. These events are known as earthquake lights. They've been documented for centuries, long before cameras or electric grids existed, and modern footage has confirmed they're real, not reflections or lens artifacts. Pausacom word text equals rare but real. Researchers believe these lights form when enormous stress builds inside certain types of rock. As the ground strains, electric charges are released into the air. The atmosphere briefly ionizes, and light appears where it shouldn't. Not every earthquake produces them. In fact, only a small percentage ever do. But when unexplained lights appear near fault zones, especially without weather activity, they're treated as a serious anomaly. In recent years, scientists have begun correlating satellite data, ground sensors, and eyewitness reports to better understand when and why these events occur, not to predict the exact moment of failure, but to recognize when the system is under extreme strain. When the sky lights up without a storm, it's not a spectacle. It's pressure revealing itself. 10. Sudden changes in air pressure and wind behavior. Air feels invisible, weightless, easy to ignore, until it changes. Before powerful storms and extreme weather events, the atmosphere often behaves differently. Winds die down without explanation. Temperatures shift suddenly. The air feels heavy, unnaturally still. This calm isn't peace, it's tension. As massive storm systems organize, they pull warm, moist air upward with tremendous force. That upward movement can briefly suppress surface winds, creating an eerie stillness. People often describe it the same way. Birds go quiet, leaves stop moving, even distant sounds seem muted. Then everything changes. Scientists track these pressure drops with satellites, weather balloons, and ground sensors. They don't look for the calm alone. They look for how fast it appears and how quickly pressure begins to fall. When these shifts happen rapidly, they signal that the atmosphere is reorganizing itself on a large scale. That reorganization is what allows severe winds, hail, and tornadoes to form. The silence doesn't mean the storm has passed, it means the system has locked in. 9. Birds and insects suddenly disappearing. Sometimes the warning isn't dramatic, it's quiet. Before severe storms and extreme weather, entire areas have gone unnaturally still. Birdsong stops. Insects vanish, the air feels empty. Pauses. In several documented cases, tracking data has shown birds leaving an area days before major storms arrive. Not flying short distances. Leaving entirely, they move hundreds of miles away, long before clouds or rain appear. Scientists believe birds can detect infrasound, low-frequency vibrations produced by large storm systems far beyond the horizon. These signals travel faster than the storm itself, and birds respond before we ever notice a change. Insects show similar behavior. Beekeepers have reported hives going quiet hours before major storms. Some insects stop emerging altogether when pressure and humidity shift suddenly. These reactions aren't panic, they're avoidance. Researchers are now studying these patterns more closely, using tracking devices and environmental sensors to compare animal movement with atmospheric changes, not to replace weather forecasts but to understand what nature reacts to before technology does. When the environment suddenly loses its sound, it's not calm, it's anticipation. 8. Vegetation dying or changing without a clear cause. Plants don't react suddenly without a reason, they change when something below the surface is wrong. before several volcanic eruptions and gas releases. Entire areas of vegetation have weakened or died with no visible explanation. Leaves yellow. Growth stops. Trees decline from the roots up. In some regions, scientists later discovered gases leaking silently from the ground. Carbon dioxide, sulfur compounds. Invisible, odorless, and deadly to roots. These gases displace oxygen in the soil, slowly suffocating plants long before humans notice anything unusual. This has happened near active volcanoes, geothermal zones, and fault systems under stress. In one well-documented case, forests began dying years before a major underground release occurred. At the time, it looked like disease, or drought, or bad soil. It wasn't. Today, researchers monitor vegetation health from space, using satellite data to track subtle color changes and stress patterns across entire regions, because plants respond early, and they respond honestly. When large patches of vegetation begin failing together, especially without weather extremes or pests, scientists look underground. Plants don't panic, they signal pauses. See a ton unusual gas emissions and strong smells? Smell is one of the oldest warning systems we have, and in nature it's rarely random. Before several volcanic eruptions and seismic events, people have reported sudden, intense odors, sulfur, rotten eggs, metallic air that burns the nose. These smells often come from gases rising from deep underground. Sulfur dioxide, hydrogen sulfide, carbon dioxide, invisible gases escaping through cracks in the earth as pressure builds below. In some cases, sensors have recorded gas levels spiking sharply, then dropping just as fast. That drop doesn't mean safety. It often means vents have become blocked, allowing pressure to build even faster beneath the surface. This pattern was observed of 4 major eruptions around the world. At Mount Pinatubo, gas emissions surged dramatically, then fell silent. Shortly after, the mountain exploded. Today, scientists continuously monitor gas levels around active volcanoes and fault zones, not because smell alone predicts disaster, but because sudden changes in gas behavior reveal what's happening underground. When the air changes without explanation, it's not imagination, it's geology breathing. Says soothing changes in groundwater and wells. Water underground is usually stable. It rises and falls slowly. Following seasons and rainfall, when it changes abruptly, scientists take notice. Before several major earthquakes and underground failures, wells have behaved unpredictably. Water levels drop overnight. Others surge without rain. Some wells turn cloudy or release bubbles that were never there before. These changes often happen when rock layers deep below the surface begin to shift. As pressure builds, cracks open, water is squeezed into new spaces. Trapped gases are released and forced upward. In multiple documented cases, chemical changes were detected as well. Spikes in minerals. Sudden changes in temperature. Unusual levels of gases like radon appearing in groundwater. None of this is random. Today, scientists monitor wells and underground water systems in earthquake-prone regions around the world, not to predict the exact moment a quake will strike, but to recognize when stress underground is reaching a critical stage. When groundwater behaves in ways it never has before, it often means the earth beneath it is no longer stable. Water doesn't decide to move, it's pushed. 5. Rising temperatures and steam near volcanoes. Volcanoes don't erupt without changing first. They heat up. Before many eruptions, temperatures around volcanic areas rise without warning. Snow melts unevenly. Ice retreats in strange patches. Steam begins to escape from places that were once cold and quiet. Crater lakes are often the clearest signal. Water that was once calm starts to bubble. Temperatures climb rapidly. Colors shift as minerals and gases mix beneath the surface. These changes don't happen at the surface alone. They come from magma moving closer. And as molten rock rises, it transfers heat into everything above it. Rock cracks, water heats stop, gas expands. Pressure builds faster with every movement. In multiple well-documented eruptions, these thermal changes were detected days or even weeks in advance. Not always dramatic, not always visible from a distance, but measurable. Today, scientists monitor volcanoes using thermal cameras, satellite data, and sensors placed directly on the slopes, not to guess when an eruption will happen, but to recognize when the system is no longer stable. When heat appears where it shouldn't, it's not random. It's energy trying to escape. 4. Small earthquakes that happen more often than usual. Not every earthquake is a disaster. Most of them are small, brief, easy to ignore. That's what makes this warning dangerous. Before some major earthquakes, scientists notice a pattern. Small quakes start happening more often. They cluster in the same area. They slowly migrate along a fault line. Individually, they don't cause damage. Together, they tell a story. These are known as foreshocks. They happen when stress underground begins to redistribute. One section slips slightly, pushing pressure onto another. Each small quake transfers energy, tightening the system like a loaded spring. The challenge is that foreshocks don't always lead to something bigger. Many times, the sequence stops. But when the frequency increases and the events stay tightly grouped, scientists grow concerned. Modern seismic networks track these patterns in real time. Not just the size of the quakes, but how close they are, how fast they repeat, and how they move underground. This is when small earthquakes stop being random. They're no longer background noise. They're pressure speaking in fragments. 3 strange colors in the sky that don't belong there. The sky changes color every day. Sunrise, sunset. That's normal. When the color feels wrong, scientists pay attention. Before severe storms, the sky has been seen turning unusual shades. Deep red in the morning, yellow-gray under thick clouds, and in rare cases, green. These colors don't appear by chance. A red sky in the morning often means moisture is already packed into the atmosphere. Storm systems in many regions move west to east, so when the eastern sky turns red at sunrise, it can signal bad weather moving in. Green skies are more serious. They form when massive storm clouds hold enormous amounts of water and ice high in the atmosphere. Sunlight passing through that structure bends in unusual ways, leaving a greenish tint below. The green design. Guarantee it, but it does signal a powerful storm capable of hail, damaging winds, and extreme rotation. Meteorologists don't rely on color alone. They compare it with radar, pressure changes, and wind patterns. But when the sky shifts into colors it shouldn't have, it often confirms that the atmosphere is under stress. The sky isn't warning us with words, it's warning us with light. Those unusual waves and ocean, babe, you're before major storms. The ocean rarely changes without reason. Its surface follows rhythms, tides, currents, wind. When those rhythms break, something large is already forming. Before powerful storms and hurricanes make landfall, the sea often reacts first. Waves grow taller days in advance. They arrive faster. They hit the coast with unusual force, even under clear skies. These aren't normal swells. They're pushed outward by massive storm systems, far beyond the horizon. Energy travels through the water long before clouds appear overhead. In several documented cases, coastal water levels began rising before the storm surge itself arrived. Beaches eroded early. Dunes weakened. Harbors became unstable. By the time the storm reached land, the coastline was already compromised. Scientists now monitor wave height, direction, and timing with ocean buoys and satellites, not just to track storms, but to understand how early the ocean responds to atmospheric pressure shifts. When waves arrive, stronger and sooner than expected, the danger isn't offshore, it's on the way. When intense sudden come before everything breaks. Sometimes the final warning isn't noise, it's silence. Before powerful storms, tornadoes, and violent weather, the environment can suddenly go still. Winds stop, leaves freeze in place. The air feels heavy, unnaturally quiet. This calm isn't relief, it's compression. As massive storm systems palm warm, moist air upward, they can briefly suppress surface winds. Energy isn't gone, it's being locked in. People who've experienced it describe the same feeling. Sound fades, animals disappear, even distant noise seems muted. Then the system releases. Scientists recognize this moment as a critical phase, not a guarantee of disaster, but a sign that the atmosphere has fully organized. Rotation tightens, pressure drops, and the window to react becomes very small. In many documented events, this calm lasted only minutes, just enough time to notice, and either move or stay. When everything goes quiet without explanation, it's not peace. It's the last pause before impact. Nature doesn't announce disaster loudly, it warns quietly through movement, through silence, through changes most people overlook. None of these signs guarantee that something will happen, and they don't appear every time. But when they do, scientists pay attention, because history has shown what happens when these warnings are ignored. The planet is constantly communicating, not with words, not with alarms, but with patterns. Understanding those patterns doesn't mean living in fear, it means being aware, prepared, and informed. If you want to keep exploring the signals our world gives us, and the science behind them, make sure you're subscribed. New videos like this are coming, focused on observation, evidence, and the moments that change everything. Thank you for watching, and remember, when nature goes quiet, it's usually saying something important.